Hey, what's up everyone? Recently I made this underwater explosion project and it was meant to be an experiment. I just wanted to see how close can I get to achieving that kind of effect using Phoenix FD alone. And there's a little bit of typho here as well, but the typho part is actually pretty straightforward. It's just a cylindrical shape that is Voronoi fractured and there's a force in the middle that is pulling it apart. And the force is animated like so, and it's making it bounce like this. So there's actually nothing special about it. I use the same force to drive the smoke towards the end to go back and forth and getting sucked towards the center here. Right, so I did a lot of experiments trying to figure out what's the best way or the most convenient approach. I just needed to start somewhere. So I thought a good place to start is to just have a liquid container using an initial liquid fill up and put some force in the middle. Here I use a spherical wind force to displace the liquid particles. And this is almost working. It forms this cavity under the surface. But when you move further on, it's obvious that there's just not enough air pressure or any air pressure at all inside this bubble to support the spherical shape. So the liquid particles are doing what they are designed to do, forming these splashes and acting as they are on the surface. And also there's not enough pressure on the outside to bring the bubble back. So I thought that probably if I fill the container all the way to the top, 100%, it will resolve at least one of the issues. And it does. The bubble is coming back. However, there's still not enough pressure on the inside to support the spherical shape. And that is simply because Phoenix's algorithm doesn't calculate air pressure in that way. And it's obviously designed to be as quick as possible. Probably 99% of the time, it's just not needed. But in the rare cases when you need to trap an air bubble, for example, inside this upside down cup, you won't be able to do so. And also, if you try to fill this bottle with liquid, you won't see any air bubbles escaping. So even if it doesn't come by default, it's not impossible to achieve that kind of effect and have the air bubbles escaping by adding an additional liquid source and a few particle tuners. And you can even simulate the displacement of the water when the air is trapped inside a cup. And as I said, it's done by adding an additional liquid and controlling it with a few particle tuners. That's probably a thing for another tutorial. Right, so back to our explosion. At this point, it was clear that I need something to support the spherical shape of the bubble, and I thought that using a geometry is the best way to do it. It was the simplest and the most obvious way anyways. So I have this tiny cylinder here in the middle that is scaling up, and it's using an animated spherify modifier from 0 to 100% and then scaling back down. So this did the trick, and the next step was to figure out how to put the actual explosion inside this cavity. Right, so at this point I had this air bubble that was nice and round, and I started thinking about all the possible ways that I can fit the explosion inside of it. I was thinking about using the walls of the bubble as an obstacle object and try to somehow fit the fire and smoke simulation inside, but I honestly didn't try that. I didn't go that far because I thought, well, maybe I can simulate the explosion by itself independently and use the liquid geometry as a cutter object. And the way you do that is by simply going into the rendering settings for the explosion. Select the cutter geometry, pick the liquid source and enable the cutter. Right, so it gets very dim, but that's simply because the bubble is outside of the liquid volume and it gets cut away. So you can either invert the liquid volume and get this result, or in my case what I did was to simply leave the cutter geometry for the explosion as it is and go inside the rendering settings for the liquid and invert the liquid volume. Actually, this is more close to what I had in my final project. I just added the blue haze for the environment by adding an additional smoke container, and the method is very well described in a tutorial made by Georgi Zhekov, and I'll leave a link in the description. So I got this far, and the geometry cutter option proved to be a great way to keep the explosion inside of the bubble. But I started wondering what would happen if the bubble was not a sphere but something more irregular. It will still act as a cutter, of course, but would it look correct? After all, both of those simulations, they don't depend on each other, they don't interact with each other. So, do I really need a liquid simulation at all? I mean, I'm not seeing the surface in the other shot, so I don't need that. And wouldn't it be possible to get this geometry directly from the fire and smoke simulation? So you simply need to go into the rendering settings for the explosion and switch the rendering mode from volumetric to mesh. Right, and if you have the IPR running, you need to restart that because in the beginning of the session the surface gets created, so you need to reinitialize that. So maybe hide the liquid because we don't need that anymore. And of course we have the cutter geometry still enabled, so disable that, and there we go. And if you want to check what's going on inside of the viewport, you can disable the GPU preview, disable the temperature, fire and smoke preview, and show mesh preview. Currently the mesh is generated based on the temperature channel, and you can use any of the other channels as long as they have some information exported inside. For example, if I choose fuel, I don't have anything inside that channel, so there's nothing to be meshed. But if I choose speed or smoke, I have different results. And temperature works just fine, and I can control the level using this isosurface level value here, and it is in kelvins. So this way I have everything that's above 1400 is getting meshed. And actually you shouldn't go below 300 because you're getting the entire container meshed, because 300 is the default temperature inside of the simulator, and 300 kelvins is, I believe it's somewhere about 27 degrees Celsius, so it's about room temperature. But 300 something works great, I believe. you can simply switch the material with some refractive material and you have something like the bubble. But the thing is, how do you get the geometry and the voxel information rendered at the same time? And the easiest way to do this is by simply hitting Ctrl V and copying this container and leaving the original render as mesh, but switch the copy back to volumetric. Right, so in theory, yeah, there we go. And if you want, you can invert the volume for the geometry one. And actually, there's a better way of doing this. If you don't want to copy the entire container, you can use a voxel shader instead. Let me just stop the IPR and get rid of the copy. Hit delete, right? So go back to where we were. And then go into the Create tab, Phoenix FD, voxel shader. Right, so you simply pick the simulator and there you go. And now it is simply a matter of saving the settings from the simulator and loading it as a preset in the voxel shader. Or you can simply quickly adjust it. And I personally prefer using the voxel shader because even if you change something in the input rollout, for example, change the source or change the starting frame or even move it like this, the voxel shader will react accordingly. So you won't have anything misaligned. So I was quite happy with how this thing worked out. It seemed simple enough and controllable. So I decided to go this way, and now there were only two things that I needed to figure out. First of all, how to avoid this lumpy look and create an explosion that was more even and smooth on the surface, and how to bring it back together. And I made a spherical source object and switch the gravity off so that the fluid doesn't rise up, and use the body force to conform it to a sphere. And the sphere is animated, it's just scaling up and back down. And when it starts to scale back down, it pulls all the fluid with it, but the fluid needs to go somewhere, so I switched the object in the center to non-solid and used the clear inside option, so the fluid just gets deleted. Alright, so here I am in an empty 3ds Max scene, and I'm going to go ahead and try to recreate the thing that I was just rambling about. So I'll need a sphere, and I'll create one and put it in the center and make it 10 centimeters. And at this point I usually remember to check my units. So I'll go into unit setup, system unit setup, and make sure that 1 unit equals 1 centimeter. Since I live in Europe, the metric system is what makes sense to me, and working in centimeters seems appropriate for this scene, so I'm good to go. I will name this sphere source, and I will make a copy, hit Ctrl V, and name this copy body force or something. I'll go into the front view and I will create a circle. and I will make it 10 centimeters and align it to the body force object. And I will also parent it to it. And I'm only doing this for visualization purposes. I don't need a circle for the simulation. I just need to see where the boundaries of the body force sphere are when it's displayed as box, because I'll be displaying it as box for most of the time. I'll select the body sphere object and I'll scale it up, make it slightly bigger so that the two spheres don't overlap and there's a little bit of a leading edge here. And I'm going to animate it, so go to frame 50. And I will use linear keys, I will adjust it later. So hit Alt key, scale it up, and then scale it back down. Something like this. I'll hide the body force and the circle for now. And I'm going to create the Phoenix simulator. Make it 50 by 50 by 50, for example, and center the pivot and align it to the source object. I am going to use the adaptive grid option, and I'll set it to be based on the temperature channel, and I'll lower the threshold to 301, and I will put some extra margin. And I might play with the scale later, but let's just leave it like this for now. I'll collapse the grid rollout. In the output rollout, I'll leave everything as it is, just the default settings. I will only lower the backup interval to 5, so that it's easier for me to restore the simulation when I'm experimenting. I'll expand the dynamics rollout, and here I will switch the gravity off. I'll switch off the massive vorticity and get rid of the cosmic vorticity as well. I'll zero this out. For the conservation method, I experimented with the smoother ones, but I found out that the buffer is actually giving me the best results. I will only lower the quality a little bit to 6, so that the fluid doesn't swirl that much. And in my original example, I was using 6 steps per frame. I'll set it to 4 for now, just so that it's a little bit quicker, and I will adjust this later if I need to. And I'm going to also reduce the time scale to 0.5. Next, I will create the Phoenix source helper. Just put one in scene, and in the settings I will add the sphere, and I'll leave everything else as it is. I will only increase the outgoing velocity to, let's start with 500. Alright, so I have the scene saved and I'm ready to simulate with the default path. So let's go into the simulation route and hit start, see what we have. And I stopped the simulation at frame 58 because it quickly became a massive 100 million cell simulation. There's nothing stopping it right now, so it keeps expanding. But I want to check the results so far, and in order to see better what's going on, I will go into the preview rollout and I will enable draw just slice option, and I'll set the axis to Y so that I can see in the front view. And I will lower the detail reduction since it was automatically adjusted during the simulation. And just by switching the gravity off, we now have a fluid that is propagating equally in all directions. It doesn't rise up. So I think this is going in the right direction, and I think it's time to introduce the body force. I will create a body force helper in the viewport. And I will hide the body force object and the circle. And in the helper, I'll pick the body force sphere. Right, so if I start the simulation now, immediately there's a problem, there's nothing being emitted. And the reason this is happening is because the body force sphere currently is set to a solid object. So I can go to Phoenix properties and disable the solid obstacle. And run this again. So the simulation had finished and I'm checking the results, and the first part seems okay, but when the body force object starts shrinking, it doesn't look like it's dragging the fluid with it, just a little bit, and also the fluid doesn't have anywhere to go. So this needs to be fixed. And I can do that by switching the object in the center to non-solid so that the fluid can enter it, and then enable the clear inside option so it gets deleted. So you can select your object, right click, go to Phoenix properties, and those are the two options that I'm talking about. But you can't animate it here because you can't drag through your timeline when this dialog is opened. So you need to open it, make your changes, then close it again, advance through your timeline, and it's a little bit clunky, but there's a better way of doing this, and it's called Phoenix property lister. So you don't even need to have the object selected. You can scrub and go to the frame you want, hit Alt key, and then you can disable solid and enable clear inside option. So now I can check if the keys are okay. And for some reason I'm not seeing it here, even though I'm filtering to show only the animated tracks. But if I disable this and hit OK, and here they are. So we have the solid obstacle going from 1 to 0 and the clear inside from 0 to 1 in frame 50. Alright, so let's start the simulation again and see what we have. Okay, so now this is what I'm getting with the default settings. And let me talk about those settings for a second. First of all, we have the strength. And if I go ahead and visualize this, I can go into the preview rollout and select the force here, add it to this list. And if I click force, I can see a preview of what's going on. It becomes obvious that this force is acting mostly outside of the selected object. And the purpose of this force is to attract fluids that are floating around towards the surface or towards the volume of the selected object. In our case, however, we already have the fluid inside of the object because it originates there. And the setting that affects it the most is this internal dampening. And the internal dampening is a mechanism meant to prevent fast-moving fluids to enter the object and then slingshot on the other side. So everything that is moving faster than this threshold here is getting slowed down. In this case, however, it just helps to keep the explosion within the boundaries of the sphere. So this seems to be working just fine. But the second part, where it is supposed to go back in and the strength of the body force is supposed to kick in, it seems like there's just not enough of it. I will increase that to 10,000. And I will run another sim to see if that helps. The simulation had finished and I will check the result. And it seems like it is doing exactly what we wanted. Well, 10,000 might be a bit strong, but I'll leave it like this for now. And I will check the mesh. So the mesh looks fine. And there are still some artifacts here at frame 30. I reckon that if I increase the isosurface level to 400, for example, they will disappear and I can further smooth the mesh. And that's all good, but I really want to know what is causing those patterns, because in some of my previous experiments it was quite severe, and I believe that the internal dampening is to blame here, because while it helps us keep the explosion contained, while the sphere is expanding and then shrinking back, it might be just enough to cause these strange patterns. Okay, so I will have to make a few adjustments here, but let me first do a little housekeeping of the project real quick. I have this little script that creates a bunch of layers for me, and I usually rename the simulator. And be aware that this will also rename the cache files on your hard drive. I'll put all the forces in the force layer and the sources in the source layer. And I will delete the rest. And I will rename my object. Okay, moving on, I will select the force and I will animate the internal dampening value. Hit Alt key and zero it out. And I will ramp it down from, let's say, 30 to, I don't know, maybe 50 or 53 or something like that. Also, I will animate the source going from 0 to 500 for a few frames. And then going back down. Alright, that's fine, I think. Let me just hide the mesh and see what's going on the dissected view. It seems like maybe I can decrease the cooling value to 0.3, for example. And let's see how this will turn out. Start the simulation. And once again I stopped the simulation halfway through because I wanted to make some adjustments, and this is what I'm getting now. And those adjustments were, first of all, in the source. I made it ramp up to 2000 in frame 3 and then go back to 0 at frame 65. And I tweaked the outgoing velocity because when you're dealing with a body force and trying to fill an object evenly with fluid, you just need to adjust the amount of material that is getting ejected, because either you have too much and it's floating around, or you have too little and you have these gaps. So you need just the right amount to fill an object evenly. And initially I made the body force object a little bit bigger, and then I just copied the key, but now I made it smaller in the end because I wanted to get inside of the source object and pull the fluid with it inside of this source object, since it is clearing and deleting the fluid, so everything disappears in the end. And for the body force settings, I increased the spreading speed to 10,000. And initially I was keeping it at the default 400. Then I tried setting it to 0 because I wanted to see if it has anything to do with those artifacts that we were seeing before. I don't think this is doing much in our case, so I think even if you leave it at 0, it won't make much of a difference. And I also increased the dampening threshold from 20 to 50 because I thought it's a good idea to have more of the fluid moving around and less of it being slowed down. But again, I don't think that made that much of a difference. More importantly, I increased the steps per frame from 4 to 6. And as you know, adding steps adds to your simulation time, but also it removes detail. And it doesn't remove detail. I mean, the voxels are still there, the resolution is there. It just smooths the velocity field. And it looks like it has less detail. But in our case, a smoother result is what we are after, so I did that. And I can go ahead and smooth the mesh once again. Go into the rendering settings and increase the mesh smoothing 25 or something. And also I may or may not change this to 400. I don't know, it doesn't make much of a difference also, so let's leave it in 301. So I went through all those steps just to have this spherical explosion, and I'm quite happy with the shape. But I'm definitely not happy with the structure inside. So I'll have to break this a little bit, and I'll do this by modulating the smoke emission and perhaps temperature emission a little bit. We are meshing all the way down to 301, so even if the temperature inside varies a little bit from 2000 to, let's say, 1500, I think it will look better, but it will still keep the spherical shape. I will do this by adding a procedural noise map to the source. So I'll go to my material editor. I'll get the noise map. And let's see, this one will be the temperature. I'll lower the size to, I don't know, 10 for now. I will animate the face, so I'll go to frame 5, hit Auto key, and then I will change this to 3, perhaps. And I'll make it linear. And I think that's too much. I'm going frame by frame, so I will lower this a bit, like this, and I'll try that again. So this looks a little bit better, I think. Okay, so I'll select my source, disable the auto key, and I will put this into the temperature. And since this is controlling the temperature, the white part will emit at 2000 kelvins, and the black part, if it's set to 128, it will be 1000 kelvins. So I will make this something like that. So it doesn't look like it has a lot of variation, but it will be enough. And I'm done with this, and I'm not interested in the preview anymore, so I will lower this to 2. I'm doing this because I remember that this was the value that I was using in my project. So I'll collapse this, hold Shift and copy it, and I'll use this for the smoke. So the smoke will be the same size, but it can have a lot more variation. Actually, a lot more. Let's make it like this. It will be the same size, and I will slightly offset the phase value so they are different. And also I will pick my source and add the smoke because I forgot to do this. Add it as an instance, hit OK. And I will run a simulation once again. And this looks like it has a lot more structure in it. And if I check the GPU preview, it looks like there are these areas that are cooler and areas that have a lot more smoke. And that is pretty much what I was looking for. And now it's time to tweak it a little bit. So I'll go into temperature and clip the values a little bit. And also the smoke. And in the dynamics route, I will reintroduce some of the vorticity. Let's go crazy with it. Let's say 0.8, see what happens. And run the simulation again. Alright, so once again I stopped the simulation, made a few changes and ran it again. And this is the result that I'm having now. In the source helper, I tweaked the outgoing velocity curve. It now goes to 2700 in frame 8, down to 0 in frame 80, and this happens gradually. And I made the internal dampening go from 0.5 to 0, starting at the very first frame and easing in and out. And I made an additional noise map and used it to mask the source emission. And this map is exactly the same as the temperature. I didn't use the temperature directly because I thought that it's a good idea to have it separately in case I want to tweak something. I didn't do this before because I was a bit worried that this might break the spherical shape, but it turns out that it only helps bring more structure. And in the dynamics rollout, I lowered the steps per frame to 4 because I thought that 6 is unnecessary, and I lowered the cooling a little bit, so now I have the temperature looking like this. And I think that's it for tweaking the simulation. The GPU preview looks good. It is spherical enough, it has these variations. It looks convincing. Right, so I will collapse the grid and the dynamics rollout just to have more space. And I'll collapse the simulation. And I'll have the preview and the rendering opened. And I can start tweaking the shader. So currently the volumetric option is grayed out because we are in mesh rendering mode. But you can easily cheat that by going into volumetric temporarily, open this dialog, and then if you go back to mesh, the button is grayed out, but if you close this dialog, it's active again, it's switched back, so you can open it anytime. And that's amusing, that's a pro tip for you. So now you can finally start playing with the shader. Adjust the multiplier if you need to, or make it the cooler part emit more or less. Depends on the look that you're after. And the GPU preview gives me a good idea of what this will look like in render. But the idea was to render this as a mesh and create a voxel shader that will take care of the voxel rendering. Unfortunately, there's no GPU preview in the voxel shader. So I'm doing this now, and I can carry those settings over to the voxel shader later by saving it into a file and then loading it. There might be some better way to carry those settings over to the voxel shader, something like simple copy paste, something that I'm not aware of. Maybe there's a script to synchronize both. I'm not sure. If anyone knows, please let me know. Alright, let's do this. I'll go into the Create tab, Phoenix FD, voxel shader. I'll create one in the scene and go in the Modify tab. I'll choose the grid and I will rename the voxel shader to, I don't know, explosion shader, for example. And before I do anything else, I'll need something like environment. And I have one prepared in a separate file, so I will merge this. It's called environment. And it only has a camera, a few lights, and a V-Ray plane. Nothing special. And I think the rendering was set to a GPU, so I might need to merge the rendering setting as well. So let's select O. Huh, Shift doesn't work. Oh, it does work. Sometimes my keyboard isn't working very well, it's cheap junk. And also my mouse, I bought this mouse for 8 level, which is less than €4, and I know that it's loud and annoying, so I apologize to you. But let's move on. Hit OK. And that's it. I have the camera, a couple of lights, and a V-Ray plane here on the bottom. I'll get a new layout, probably something like this, and I'll set this to camera view and show the save frame. And let me open the frame buffer, and I will isolate the shader. It is set to V-Ray GPU, so it's compiling the kernel, and that's it. And now if I had saved the settings from the explosion, I could have loaded here in the preset. Actually, the button is down there, but let's quickly adjust this. Alright, so first of all, when using the GPU, you get a bunch of errors here in the log, and they simply say create firelights is not supported, and also the volume light cache is not supported. So I'll switch that off and clear this, because it keeps popping and it's annoying. And now I can set the smoke from simple smoke to smoke and play with this curve. And the areas that have less smoke, I'll make it even less. Right. And the areas that have more smoke, I'll make it more dense. And I can of course play with the color. And you can of course play with the absorption value. So if it absorbs less, it's darker, and if it absorbs more of the light, more of the light is getting scattered and bounced around. And you can play with the emission curve, of course. And for this curve to have greater effect, you might need to lower the physically based value. And you can increase the fire multiplier. And really play with these settings. It's really up to you and the effect that you're trying to achieve. And I'm not going to tweak this shader any further because when I start tweaking things, it can take hours and I dragged this video for too long. So let's move on. Now I have the voxel shader rendering as volume and the explosion itself rendering as a mesh. And I can go into my material editor, get a V-Ray material, assign it to the explosion, and then let's see if I can show the frame buffer in the recording. There it is. So I will make it refractive and I will put some reflections. And that's pretty much it. Of course I can invert the volume. And there you have it. There's one last thing that I want to show you. And that is now if I show the mesh for the explosion. And it is inverted. Notice how when I scrub through the timeline, the whole thing is changing its size. And one way to fix this is to get rid of the adaptive grid, make the grid bigger from the very beginning and then simulate again, and that will take more time and it will produce larger cache files, but it's one way to do this. But there's another way and it's probably quicker. I will create an empty simulator and put it in this layer. And isolate it. And now if I click show mesh, even if I switch the surface to be generated based on temperature and lower this below 300, and it seems like the default is 0.5, which is way below 300, but still there's no mesh being generated because there are no cache files being associated with this grid, and in fact there's no temperature channel whatsoever. Right, but you can easily fix that by simulating a single frame. And you need to go into the input settings and set the mode to cache index so that you have this one single file through all of your timeline. And I was planning to get the information from this single cache file and load it as a texture and combine it with the other one, may probably subtract the original explosion. And that might have worked. However, you can't change the size later because you're fixed to this one single cache file. So as I was trying to figure this out in my head, it hit me that there's in fact a lot better way to do this. I will get rid of this one single file. Right, so I have an empty container. I will go into my material editor and get a Phoenix FD grid texture, and I will plug it in the first slot so that I can switch to the compact view. And that's better, we can now work on one monitor. So in the Phoenix FD grid texture, I will pick the original explosion and I'll get some information inside. And I will select this grid that we just made, the empty one. And I will set the surface channel to texture, and I will plug this texture here as an instance. In the channel dropdown, I have to select something that is more appropriate. For example, grid temperature. And I'll have to rescale those values, and you can do this automatically by pressing this button and rescale to this frame. Okay, so this is working. You have something. And if I show the original explosion, I can simply switch this texture to be applied in world coordinates. Right, so I can now invert this. Make it see-through. And I can place it somewhere more appropriate. And it looks like the texture is following the grid, but if I go one frame forward and one back, it snaps back in place. Right? It's just not updating properly. And the reason I'm doing all this is because now if I unhide the ground plane, I can put this grid on the ground like this. And now I can make it as big as I like. Not to mention that I can change the resolution on the fly. And the applications for this might be, let's say, for example, if you're simulating a swimming pool, making liquid simulation, and you can simulate only the surface and then make it as deep as you want, and also as wide as you want. Well, I'm going to wrap this up. I just wish to say a few final words. I am most definitely not trying to say, you see, this is how you make an underwater explosion. Obviously, there are plenty of ways to tackle this kind of task. The whole thing started as an experiment. I just wanted to take Phoenix for a test drive and see what it's capable of. And obviously, it has so many options and it can handle a broad range of tasks. So I have to say, it did pretty well. I did encounter some issues and a few bugs, and I reported all of it, and they were resolved in a matter of days. So kudos to the development team for all the support and the job they're doing. And that being said, you should probably download the latest nightly build. Alright, I hope you liked that video and take care.